Hello student, welcome to the lecture number 26 in Petrochemical Technology, and the new topic we will study here into this is visp breaking and coking process. So visp breaking and coking process is also a very important unit into the refinery where we crack the heavier hydrocarbon to improve its property which is marketable. So coming on the definition of the visp breaking. So visp breaking and coking are two different refining process employed into the petroleum industry, and both have the aim at converting heavy hydrocarbon into lighter or more valuable product. So while they share the objective of the breaking down heavier fractions, they differ in their operating conditions and end products. So operating conditions are changed into the both of the process. So first we will talk about the visp breaking process. Visp breaking, short for viscosity breaking. The short name of the visp breaking is viscosity breaking. Is a thermal cracking process used to reduce the viscosity of heavy residual oils. So we reduce the viscosity of heavy residual oil into visp breaking process. So the primary purpose of visp breaking is to upgrade heavy fractions from the crude oil by reducing their boiling range and viscosity to yield more valuable products such as gasoline and diesel. So how this process takes place, we will talk into this slide. So in visp breaking, the feedstock is typically or heavy residual oil or vacuum gas oil is heated to a temperature typically that is between the 870 to 900 degree centigrade. Oh sorry, degree Fahrenheit, or 465 to 480 degrees centigrade in a furnace that is called a visp breaking unit. So this moderate thermal cracking process involves breaking the long chain hydrocarbon into lighter components through controlled heating and short resistance time, that is usually less than an hour, into the visp breaking unit. So here we are maintaining the temperature up to 870 to 900 degrees Fahrenheit, up to 465 to 480 degrees centigrade, and the mm, uh, the heating time is very short, that is less than 1 hour. So the heated feedstock is then rapidly quenched and cooled. After the heating, the feedstock is rapidly cooled. It is cooled very fast or it is quenched in a cooling tower to stop the cracking reactions, and resulting products are separated into lighter fractions. So once they are heated, they are cooled very fastly so that the cracking reaction should not place. The heavier hydrocarbon should not be cracked, only to improve the viscosity. And the resulting product will be again separated into the lighter fractions such as gasoline, diesel, and atmospheric residue. The another process is very important, that is coking. This refers to the conversion of heavy residual oil or bottom into lighter product by subjecting them with high temperature. So this is also a very high temperature reaction, and it is converting the bottom residue into the lighter product. It involves the thermal decomposition of heavy hydrocarbon to produce valuable product and solid carbon residue, that is called a coke. So we have the type of coking. The first one is delayed coking. This is the most common form of coking. In delayed coking, heavy residual oils are heated extremely at very high temperature, usually around 900 to 950 degree Fahrenheit or 480 to 510 degrees centigrade for an extended period, typically over an 24 hours. So this here the temperature is also very high. You can see 480 to 500 degrees centigrade, and it is heated up to the longer period of time, more than 24 hours, in large coke drum or cooker. So high temperature causes the hydrocarbon to crack into the lighter fractions such as gasoline, diesel, and gas oil. And solid carbon residue, that is bottom of the coke drum, in the form of coke is left behind into the coke drum, And how this process takes place, we will come to know into this slide. The feedstock is pumped into the coke drum and heated to the desired temperature, that is 480 to 510 degrees centigrade, where the cracking of heavy molecule occurs and yielding lighter hydrocarbon product. And the coke, which is solid at the room temperature, is subsequently removed from the coke drum and can be further processed if some valuable hydrocarbons are available into it, burned as a fuel, and this can be also used to burn as a fuel or causes in other industrial application. So if you talk about in summary, the visp breaking and coking are thermal cracking process used in the into the refinery to convert heavy hydrocarbon into lighter or more valuable product. Visp breaking aims to reduce the viscosity and boiling range of heavy oils to yield lighter product, while coking involves subjecting very heavy oils in high temperature to produce light product and solid coke residue. So both the process play crucial role in maximizing the yield of valuable product from heavy crude oil, fraction and residual oil. So here this is the typical diagram of coil with breaking process. This is a coil that is used for heating purpose. You can see the temperature range is 885 to 930 degree Fahrenheit, and it is heated up to 1 to 3 minutes of duration. And here the feed is sent into this coil within the range of 1 to 3 minutes, and after that it is uh, cracked, viscosity is reduced, and then it is sent to a quench tower. This is a quench tower or cooling tower from where we are recovering the top product as a gas, gasoline, light gas oil, heavy gas oil, viscosity broken oil, fuel oil. Here this is another diagram that is having the coil, that is VDR, and the temperature ranges is 800 to 830 degree Fahrenheit, and time is 5 to 8 minutes. This is the duration through which this feedstock passes through this coil. Low energy consumption. So this is a soaker drum, that is like a quenching tower, right? It cools down the product, and here this is a fractionator. We separate the different product into the fractionator. This is another process diagram for delayed cooking and fluid cooking. You see this is a furnace that is heating, and this is a coke drum where we will send the feedstock after heating. So after traveling through the coker drum at very high temperature, this is coming to the fractionator section, and into the fractionator section we are separating the gas and gasoline and gas oil. This is again the recycle, the heavy residue goes to the heating back into the furnace, and again if there are some valuable product further, it can be recovered into the fractionator. And talking about the another diagram, that is fluid cooking, you see there is a reactor and this is a burner. So feed is passing through a reactor and coming to the product fractionator, and then the bottom product is going to a burner where it is heated, and at the top you are getting the flue gases and product code, different product code. So this was all the information about the visp breaking and coking unit. So next topic we will discuss into the another lecture. For any question you can email me or write it down. Thank you.